work with this. All right, guys. Wishies can stay with you here, but we got work to do. All right. Now, this first example, give the parent function name, describe the transformation represented by the equation, then graph the parent function and the given function on the same grid. Give the domain and range of this, okay? You don't, not the parent function, but that one, okay? So, all right. What's the parent function name? Vincent?
Quadratic.
This is a quadratic. Okay, I'm going to make the quadratic of the parent function. I'm going to make a table, I mean. -3, -2, -1, 0, 1, 2, and 3. X squared. What is that? 9, 4, 1, 0, 1, 4, 9. Is that coming to you fairly naturally now? And then 2x squared. So 9 times 2 is 18. 4 times 2 is 8. 1 times 2 is 2. 0 times 2 is 0. 2, 8, and 18 here. All right. So it said graph the parent function. I'm going to do that in pencil. How many times have we done this? A lot? Yeah, and whatever it is for you, multiply it by 3 and you've got it for me. Because I have 3 sections of this class. Although you do it more in practice. Okay, so here is, all right, there's our parent function. That's f of x equals x squared. Just write it beside it there. All right, I'm going to change colors. If you have that ability and you'd like to, that's fine. You can do that. Now, -318, that's not going to fit on our grid the way I've got it scaled, right? I've got it scaled by 1, so that's just not going to fit. So let's graph the first one we can, -2, 8. So you see -2, 4 is here, but we're going to -2, 8. 5, 6, 7, 8. -1, 2. 0, 0. 1, 2. 2, 4, 5, 6, 7, 8. 2, 8 there. And see how that's skinnier? It's inside the parent function. And that's f of x equals 2x squared. All right. Any questions there? No? All right. Okay, a function's parent function is the absolute value function. And it is being reflected over the x-axis. All right, give the equation of the transformed function. All right, so it's f of x equals, it said absolute value, right? Reflected over the x-axis. What does that? What makes it reflect? Put a negative out here. That's the only transformation they talked about, right? So let's just put... Any questions on that? Got number 2 written down? All right. Number 3, give the equation of the translation graphed below and state its domain. Oh, okay. We'll go back. I didn't do the domain and range of this one. We'll underline that so I don't forget to do it on this one. And then we'll go back to number 1 and get the domain and range of the transformed function. All right. What's one thing you do know here? What kind of? It is a quadratic. Okay, good. So I'm going to write, I don't think I'm going to write parentheses because I'm not moving it anywhere. You see what I'm saying? So I'm just going to write x squared. What has happened, though? Vincent?
I'm guessing the equation was upwards, and now it's been reflected down.
Yes. What makes it do that?
A negative.
Okay. So you said it was the parent is upwards, now it's facing down. A negative is going to do that. This looks a little bit skinnier than the parent function. All right? What I'm going to do here is, if normally in the parent function, if I go over 1, since I'm flipping it, it would be down 1, right? Well, how far down are we going here? I don't think it's hitting there. I think it's hitting right here and right here at 1 and negative 1. Are you seeing that? Seeing? Okay. So normally we would have 1, but we are not having just 1. We are multiplying it by an a value. And when we do that, we're getting, I should say negative 1, right? Negative 1. When we do that, we're getting negative 3. Negative 1, negative 2, negative 3. So rather than being at negative 1, we're multiplying it by something and getting negative 3. Do you see that, guys? That helps me find the a value. Now that's the absolute value. Vincent already told us it's negative, so f of x equals negative 3x squared. I think finding that a value is the trickiest thing here. All right, but do you understand the method we do? If you have some knowledge about the parent function, you can figure out what that a value will be. Okay? Now, let's turn it over. Oh, okay. Domain and range?
Yeah.
Yes, thank you. All right. Yes, thank you. What is the domain of this one? Yes.
Negative 3.
Okay, you are probably looking more. Just look at the graph. Look at the graph. How far right and left will it go? Yeah. Domain on these is pretty consistent. Okay? Now the range. The negative 3 is just to kind of help us out with this. So how low will this graph go? Now, if I put arrows here, how low is that? Negative infinity. Good. Is there a high point that it's going to reach? And what is that? 0. And is this a closed circle? I mean, is this an open circle? If it's an open circle, I'll write this. If it's included, I'll write that. Okay? Now, the pink graph here. Domain. Is pretty much the same here. But the range, what's the low point? Zero. So let's inclusive. And how high will it go? Okay. All right. Now don't forget to do that. Like I did. Several times. Thank you for the reminder. All right. Give the parent function name. I'm going to get you started. I'm going to let you work on this packet. Let's get this one started. Actually, how many more pages do I have? I got 2 more sets. Yeah, we'll do this one together. Give the parent function name and describe the transformation represented by the equation. Then graph the parent function and the given function on the same grid. Give the domain and range of this. All right, so parent function is what kind? Absolute value. Is everybody's good with that? Very good. X, absolute value of X, -2, absolute value of X. Okay, so what's going to happen to this? I'm not sure I describe the transformation represented by the equation. Just curious, did number 1 ask me to do that? Yep. Okay, I forgot, but let's not forget on this one. Read the instructions, guys. Golly, Ned. Okay. Describe the transformation. What's going to happen to this? Because of this -2. Alex. It will reflect over the x-axis, right? Things can reflect over y-axis too, but this is specifically just going to reflect over the x-axis. And what else? Squish or stretch? Just ignore the negative when you're thinking of this. It'll stretch by a factor of 2. Okay? When the absolute value of that number is bigger than 1, we're stretching it. Now we're also flipping it. All right? Alex, is that good? The stretch? Okay. All right. Let's go -3, -2, -1, 0, 1, 2, and 3. 3, 2, 1, 0, 1, 2, 3. Just absolute values on that, right? Now, absolute value of x, -2 times absolute value of x. 3 times -2 is -6. 2 times -2 is -4. 1 times -2 is -2. 0 times -2 is 0. 1 times -2 is -2. -4. And -6. All right. See if I got any green ink left here for that one. Not much. All right, I'm going to graph the parent function in pencil. And now I'm going to graph this. I'm going to actually put the points down on that one. -3, 6. 1, nope. -3, -6. 1, 2, 3, 4, 5, 6. negative 2, negative 4, 2, 3, 4, negative 1, negative 2, 0, 0, 1, 2, 1, negative 2, 2, negative 4, 3, negative 6. Okay, so does this one look thinner than the parent? Okay, so it did get stretched. And you could have stretched it up here and then flipped it. We did both things when we did the negative 2. All right, number 5. A function's parent function is the quadratic function, and it is being dilated by a factor of 3/4. Go ahead. Let me have it. Go ahead, Vincent.
Are we going to do the domain and range?
Yes, we're going to do the domain and range. Give the domain. Would you guys please follow the instructions? I know. All right. What's the domain? Maybe it's... I'm going to blame him. Okay? All right. Keeps looking at me. All right. The range. What's the range on this one?
Is it negative infinity 0?
It is. 0 with what kind of bracket?
The sharp one. The one with the point.
Yeah. This sharp, pointy one. Okay. All right. Good. A function's parent function is the quadratic function, and it is being dilated by a factor of 3/4. Dilated means we are doing this to it, right? We're squishing it. Here's 1. This is less than 1. This is bigger than 1, right? Let's put 3/4. It's quadratic, so what should be here? X squared. Very good, Alex. All right. One more. Okay, we're not moving it, so I'm just going to put the absolute value of x, but there is something happening here. Normally, the parent function would be 1, 2, 3, like this, right?
We can't see that.
All right. 1, 2, 3, 4, 4, 5, 5, and so on. Just kind of looking at what the parent function is doing here. I'm not going to use this one. I'm going to go over here. Okay? 2, this is from the parent, times a. So this is a parent coordinate. Times a, and then to the transformed. 2 times 1, 2 times a is equal to 1. Does everybody see where I'm doing this right here? The y coordinate here is 2, that's that, times a is equal to the y coordinate here of 1. So a is 1/2. All right? This guy's getting squished. Right there. All right. I'm going to have you work on the packet. I want you to get it done. If you don't get it quite done in class, it's just 2 pages of this kind of stuff. I'd like for you to finish that.